They have given particles of masses capital 2m, okay, and small m and capital M. Respectively, they are placed at the points A, B, C, and they have also given the relation between the distances, that is AB is equals to half of the B. Now, they have not only that, they have also provided that this small mass m, small m is where this mass small m is very much smaller than the mass capital M. And at t is equals to 0, they all are at rest. Means at t is equals to 0, there is no kind of movement in these particles is observed. Means they are all are at rest at their respective positions as shown in the figure. At subsequent times, before any collision takes place, now they are asking us to verify these four options. So at the subsequent times, what does this subsequent times means after the time proceeds in the further time, what happened before collision, what takes place, means what kind of the movement of the mass m takes place. So whether we need to identify whether this small mass m, whether it will move towards this capital M, or whether it will move towards the mass 2m, we have to identify, or whether it will perform any oscillator motion, we have to identify that. As the time proceeds, what is happening over here, in order to understand that, let us find the force acting on this mass, small m. So let us denote the force on B due to A. Okay, force on the particle present at B due to A is equals to G capital M, okay, capital 2M into small m by R. Distance between AB is R, so it will be R square. Okay, the force on the B due to this mass to capital 2M will be equals to 2G capital M small m by R square. Now, similarly, when I find the force on the B due to the mass placed at the point C will be equals to G capital M into small m by distance between the two B and C is 2R. So we get that 2R square. So, in order to compare which of the following forces, that is force exerted by particle at A is greater, or whether the force exerted by the particle at C is greater, in order to understand that, let us denote G capital M into small m by R square, this term by capital F, so that it will be easy for us to compare. So when I find the force on B due to the capital A, it will be equals to 2F. And similarly, when I find the force on B due to the capital C, it will be equals to F by 4. So you can observe clearly that the force exerted by the capital particle placed at the capital A point is greater than this mass. Okay. So what we can observe that the resultant net force is acting towards the mass 2m. Okay, the net resultant force acting on this small mass m is towards this capital A point. So that this mass m, which is placed at the point B, it will start moving. It will start moving towards the capital A, and after some time, it will collide with this mass. So now they are asking us what happens before collision takes place. That what is happening before collision? Before collision, this mass m is moving towards the moving towards the mass 2m. So in the option C, it is clearly defined. So our option C is true.